All right, today we're going to be talking about three different ways where we can measure the corrosion rate. So think of all these are going to be in context of a pipeline, and think of how do we measure this? We can't just cut open the pipeline every day and see if it's rusting or not, right? That's really expensive. That's really dangerous. There has to be a different way. So the first way is called the weight loss method. That's when we take another steel that's the exact same steel as a pipeline. It's called a coupon. It kind of looks like a rectangle, the same size as a hockey puck, and you weigh it before you put it in. So let's say we weigh it at 100.00 grams, right? It's really important to be precise because corrosion, you don't lose a lot of mass from corrosion. So we weigh it and it says 100.00 grams, and we put that little coupon into, we call it a coupon holder, right? Because pipelines have these special fittings where it's like a little door where you could put it in, screw it in, and then you slide it into the pipe. And that coupon is experiencing exactly what the pipe wall is experiencing, the same pressure, the same temperature, and also the same corrosive fluids rushing past it. So now we leave it there. We leave it there. It could be 30 days, 90 days, whatever. And during that time, the corrosive fluids are rushing past it. Corrosion's happening on the surface. The metals are getting eaten up and washed away. And after 90 days, we come and collect the coupon. It's all rusty and pitted. It probably looks disgusting, but we rinse off the rust part, making sure we don't scrub off any of the underlying metal, and then we weigh it again. And now it weighs 99.5 grams. So we've lost 0.5 grams, right? So now what do? We have the math. We can do the math now. We know how much weight has been lost, 0.5 grams. We know the surface area, let's say it's like 10 centimeters square. We know how many days is in there, 90 days, and we know the density of steel, which could be like 7.8 grams per centimeter square. I don't know, I made that up. But basically, if we know that, oh, let's say we left it in there for a year, right? And 0.5 millimeters of that steel got corroded, and let's say the pipe is 10 millimeters thick. Now the pipe has about 20 years of life left before it gets dangerously thin. So that's the type of math we can do with a weight loss method. But let's say that we don't have 90 days or 30 days because let's say the corrosion inhibitor chemical, the chemicals we put into the pipeline to kind of prevent corrosion, let's say it stops pumping. The pump for that stops running into the pipeline. Now we got a problem. So we need a solution now, and that solution is called the electrochemical method. Electrochemical method is a lot easier. Basically, we stick a probe in. Probe is kind of like the coupon thing we are talking about. It's the same metal as the pipeline, and we stick it into the pipe, and then we connect a wire from the probe to a potentiostat, right? So I'll talk about more about that later. And then we connect another wire from the potentiostat to the pipe wall. So now we have the potentiostat, and we have a wire connecting to the pipe wall and the wire connecting to our probe. And we run a little circuit, right? So this potentiostat gives a little nudge to the probe, and that probe pushes back with a small current, and that box now measures the current. So with a high current, we know that it'll be a fast rate of corrosion, fast way to get rust. And with a low current, it'll be like a slower rate of corrosion. So that's another way. That's the second way we can measure corrosion rate. The third way is we take kind of that information and we put it on a plot. So time to open up Discord again. And this is it, right? This is the anodic reaction. This is kind of what we looked at the last video, but it's more realistic because it's curved. And this is the cathodic reaction. And then we draw a linear line for where the linear part of it is, and we extend it. We extend it because we want to find where the I core is. I core, remember from last video, is the same rate of reaction when they're both the anodic and the cathodic reactions are happening at the same time. And this is the rate of reaction. So this is what we're trying to find, I core, and this is the TAFL. It's called the TAFL extrapolation. Is the third method on finding corrosion rate. So thank you for watching my video, guys. Hope you enjoyed.